Hello, this is Professor Norman again, and this is our third video on the six-step diagnostic process. We've already covered step 1, 2, 3, and 4. So we covered number 1, verify the customer's complaint. Number 2, determine related symptoms. Number 3, analyzing the system, figuring it out. And then number 4, isolating the system. Now, on the previous video, I mentioned a little bit about the diagnostic book. And so what I'm teaching you is a advanced diagnostic process where, someone with experience, someone that understands electricity, understands the system, understands testing techniques, how to use your voltmeter, how to use your test light, understanding everything there needs to know about diagnosis of the system. So I did mention the diagnostic procedures, and so here's an example of one that this is probably backwards, but this is an example of one that I had for my older Dodge truck that I had back when I used to work for Chrysler. But the key is that if you have a new technician, if you have someone who doesn't understand how to do diagnostics, if you have someone who doesn't understand how to read the wiring schematics, doesn't understand basic electricity, doesn't have a lot of experience, and this is what this diagnostic book is for. Even someone like myself with, again, lots of experience, if I came across a brand new vehicle I have never had any experience with, and I didn't understand the system, well, I'm probably going to go to a diagnostic book, try to find out what the symptom is, and maybe follow it to give me some guidance as far as what's going on. So be aware that this is a tool to use, and obviously if you're stuck in your diagnostic process, and if you cannot isolate, you have not been able to narrow it down, you don't know where to begin, it's probably something that happens a lot of times, you just don't understand what's going on, then obviously look for the diagnostic procedure and look for the symptom or the fault code and start following it, and hopefully it will follow you down to the path of the problem. When I worked for Chrysler's, technicians would never say, I was diagnosing this procedure and I was on step number 13 and hey, I found the problem. They didn't come to me and say they had a problem following this procedure. The problems or the concerns that came with me would be that, hey, I followed this procedure and I couldn't figure out what's going on. It told me to replace the computer at the end. I replaced the computer and I still have the same problem. What's next? And so again, this process of the six-step diagnostics process is going above and beyond this. It's thinking outside the box, using logic, using your problem-solving skills, saying, hey, you used all the other resources and you can't find the problem. This is a kind of a hard issue, something that hasn't been experienced before. You need to figure out what's going on. When you start thinking about all the problems that could be on the car, there's no way somebody could write every single problem, every single procedure in a book. There's just too many of them. There's thousands and thousands and thousands. And so you need to be able to understand diagnosis. So when the problem is not in the book, if the book is not following the process to be able to figure out what's going on, you're able to be able to think on your feet. Again, this thing that we call diagnosis, and be able to fix the problem, solve the problem. So we're going to go ahead and go to the next step of this process, and I'm going to go ahead and share the screen so you guys can see what's going on. And so again, we got our first 6 steps, and so after we have isolated it down to what we have determined as the failure, and we have confirmed that component is bad. So there's typically more than one test that you run. I typically tell my students hey, I want to confirm something. If you think something is open and your ohmmeter needs to say OL on it, if something is mechanically broken, you should be able to see it, you should be able to feel it, you should be able to hear it do something. And so the key is that you should have a very high probability of it being bad. So the next part of the process, after you can determine what component is bad, it could be something as simple as a wire that's open. It could be a component that's bad, something that's electrical, something mechanical, something like that. The next phase of it is actually to repair the problem, which is sometimes easier said than done. If you say that, well, there's an actuator that's bad in the HVAC assembly, but the actuator is on the back side of the HVAC assembly. It may require you to remove the whole entire HVAC assembly, which could take hours in order to repair that, or it could be a broken door in there that is not moving. The actuator is moving, but the door is not moving. And so again, that repair can be very, very involved. Could be something as simple as replacing a pressure switch. You just unscrew the pressure switch, you put the new pressure switch back in, you plug it in, and then now the AC is working again. So again, the repair is typically the easiest part of the process. It could be time consuming. I mean, again, it could be very, very time consuming. But again, as far as the repair itself, that's easier to teach someone to do the repair than it is to teach someone to do the diagnosis itself. So once you have the repair done, then what's our next step after that? And so to finish off this process, the key thing is that you need to start off with what you started out with, which is verifying that everything is working correctly. And this is incredibly, incredibly important in the world of OBD2 diagnosis, where when you have a failure, some monitors may turn off, some things may not operate correctly or not operate at all. And so you may have more than one problem that you don't realize. And so I remember a student brought in an older Mustang, like a 90s model of Mustang, and they bought it used, and the air conditioning has never ran. So they wanted to diagnose it. They wanted to bring it in and see what was going on, and hooked up gauges. And there was no refrigerant in there. So they said, oh, okay, I'll just put refrigerant in. Well, they put refrigerant in and it leaked out. And so there was a hose that was leaked. That was a pretty easy fix. So they ordered a hose, they put a hose in it. Okay, got the hose in, made sure there was no leaks in it, put the right amount of refrigerant in. Then when we turned it on, it didn't turn on. And so, diagnosing a little bit further, and then there was a wiring issue, and so he had to fix the wiring on it. So he got the wiring fixed on it, and he now hits the button again and turns it on to verify the complaint. And the compressor is making a terrible, terrible noise. It's like this compressor is just not it's not in good shape. I mean, it's going to lock up. It's terrible. It was open for so long. The system was open for so long, had moisture in the system. I'm sure that the compressor was all rusty and stuff. And so he ended up replacing the compressor, replacing the receiver dryer. Gone through a very, very good repair. Okay, he started it up, and hey, now it's starting to blow cold air. And I think in the classroom time, we only have 2 hours to work on a car, and so he kind of skipped this last process to verify and repair. He turned it on, the AC was working, he was satisfied with it, and he left. Well, he comes back next week and say, hey, now my car's overheating. And so the key is that now with the air conditioning on, with the extra load on the engine, that realizing that now he had a electric fan problem that he had to diagnose. And so the key is that you need to make sure that with an air conditioning system, let's say if that's what we're still working on, is that you're just not just kicking the system on and just making sure that it blows cold air and okay, we're done 2 minutes and now skip to the customer. You need to make sure that the engine's fully warmed up. You need to make sure that the system is working. You need to go in and go back to what we call determining related symptoms. Go back and look at everything that's involved and make sure that everything is functional, making sure that the blower motor is still working, and making sure that all modes of operation is working, and making sure that those fans do come on, and looking at your pressures and getting the engine warm and making sure that the pressures aren't too high. Making sure that they're not too low. And so you want to make sure that your customer is satisfied, and you don't want to, the worst scenario is you come back, the customer comes back a week later with either the same problem or a similar problem in which you didn't go through and do everything that you need to do to verify the repair. And that's the 6-step diagnostic process. Be aware that you need to be able to explain this to people. You need to be able to identify what you're doing in this. I do know that Ford, for an example, Chrysler, for example, has used this as a question for an interview. So they would verbally ask you, hey, explain to me how to diagnose something. And so they're not looking for the very specific issues of an engine diagnosis or the very specific issues of an automatic transmission diagnosis. They're asking for the big picture. So they're asking for your process. They're asking you, hey, I got to first verify the customer's complaint. I got to determine related symptoms. I got to then analyze. And they may say, well, explain what that means. What does analyze the system mean? Well, analyze the systems means I have to figure it out. I have to understand how it operates in order for it to diagnose. Then I have to isolate it down, and then I have to repair the system, and then I have to verify. And they may say in an interview, well, can you explain to me how would you verify a engine misfire problem? Well, now you got very specific details, and so you could then go into detail on that. Ford has used that as a writing sample. So on some interviews, students would have to write how they would diagnose a particular problem, where you would have to give very, very good information about verifying the complaint and then determining related symptoms and so on. Or they may say, how would you analyze the system? Well, I would say if it's an electrical problem, I'm going to go to the wiring schematics right away to try to see what components are involved in the system to make sure that I understand it correctly. You will need to be able to understand this process for class and for any test that you may have to go in and actually explain these 6 steps and what each 6 steps mean. Good luck, everybody.